this was not ordinary fire. This was the machine that began to break the darkness. Inside it, gravity pulled everything inward, while nuclear fire pushed back from the heart. When that fragile balance began to fail, space itself seemed to wake. A star was dying, yet the universe was preparing to be reborn. At the final moment, the core was crushed by the weight of its own existence. Then, a single explosion illuminated a region once ruled by darkness. From the ashes of one star, carbon, oxygen, and the seeds of complexity began their journey. Everything familiar to us today was once touched by furnaces like this. But the story did not begin with the death of stars. It began when there were no stars at all. There was a time when the universe had no night sky, no galaxies, and not a single star. In its earliest age, the universe was a hot sea of energy where light could not travel freely. Photons were trapped, bouncing again and again through matter too dense to see through. But the universe kept expanding, and as it expanded, it cooled. When the first atoms formed, light was finally released. The echo of that release still surrounds us, as the infant portrait of the universe. After that first light, the universe entered a strange era, the cosmic dark ages. There were no stars to shine, no galaxies to take shape, only gas, gravity, and time. But hidden inside that silence were tiny irregularities, small seeds of future structure. Dark matter, unseen yet gravitational, began drawing the first skeleton of the cosmos. Where those filaments met, primordial gas slowly gathered. Atom by atom, hydrogen began falling into the first gravitational wells. The more the gas collapsed, the denser and hotter its heart became. For a star to be born, gas had to lose heat, allowing gravity to gain the advantage. A single cloud did not create only one star. It broke into many seeds of light. At the center of one such seed, temperature climbed with every passing moment. Gravity pressed inward. Heat pushed outward. The battle that creates a star had begun. In a place that had never known sunrise, the universe prepared to ignite. No eye witnessed this moment, but physics preserved its fingerprints. When the core became hot enough and dense enough, hydrogen was ready to fuse. Hydrogen became helium, and a tiny loss of mass transformed into enormous energy. At that instant, a real star was born. Its ultraviolet radiation began breaking apart the hydrogen around it. Each powerful photon acted like a key, unlocking the atom into its smaller pieces. A bubble of light expanded inside a universe that was still mostly dark. Then there was not just one. Many of the first stars began to awaken. These earliest stars may have been enormous, extremely hot, and short-lived. Each cluster became a workshop of energy, turning simple matter into cosmic history. But light could also be destructive, stopping new stars from forming too close. In the early universe, the birth of one star could reshape the fate of its neighbors. From quiet darkness, the universe became a stage of violent motion and radiant change. Light did not merely illuminate. It carried information, pressure, and power. A photon could leave when the universe was young and reach our telescopes only after more than 13 billion years.
To understand the age of stars, we must enter the inside of a star. Gravity always tries to crush a star into its own center.
But the heat from nuclear fusion creates pressure that pushes back. When those two forces balance, the star lives. In the core, hydrogen is fuel, and helium is the first product of the cosmic furnace. Energy born at the center does not escape instantly. It must cross a dense plasma labyrinth. A ray of light may wander for a very long time before reaching the surface. Near the surface, hot matter rises, cools, and sinks again, like a colossal boiling ocean. When energy reaches the surface, it becomes light that the universe can see. A star is a continuous truce between collapse and explosion. From the fierce core to the radiant surface, every layer has a role.
Magnetic fields turn the stellar surface into a storm with shape.
Where magnetic fields are strong, the surface can become cooler and darker than its surroundings. Sometimes trapped energy breaks free as a stellar flare. Stellar winds carry matter and energy far from their source. A star never lives alone. It constantly sculpts the environment around it. But no furnace burns forever. The fuel in the core will eventually run low. A star's life depends above all on its mass. Small stars use fuel slowly. They can live longer than the current age of the universe. Massive stars live fast, shine hard, and die young. Mass is destiny. The heavier the star, the hotter and more violent its core becomes.
When hydrogen runs low, massive stars can continue forging heavier elements. Near the end, a giant star becomes layered like an onion of elements. Iron is the dangerous stopping point. It no longer feeds the star with energy. When the core can no longer support itself, the entire star becomes unstable. When gravity wins the final battle, the death of a star becomes one of the brightest events in the sky. A supernova is not only an ending, it is a cosmic act of seeding. The shockwave compresses nearby clouds with enough force to awaken new star formation. Elements needed for planets and life are thrown into space. The death of a star becomes a beautiful cloud of new material.
If the core is dense enough, it can become a neutron star, small in size yet unimaginably heavy.
Some remnants spin so fast, they sweep beams of light across space like lighthouses. For even more massive stars, Gravity may create a region where light itself struggles to escape.
A black hole is not a monster. It is gravity pushed to its extreme. Around such endings, new clouds are already preparing to collapse. The next generation of stars is no longer made only of hydrogen and helium.
With each generation, the universe became more chemically rich and visually complex. Stars do not merely live and die. They create a cycle of birth, transformation, and rebirth. In disks of dust around young stars, matter begins to cling together. From dust grains, the future of planets begins. Without earlier stellar deaths, there would not be enough material to build rocky worlds. A single carbon atom may once have lived inside the heart of an ancient star. The age of stars is an age of continuous transformation. From a few first flames, the universe became an ocean of galaxies. When stars gathered under gravity, the first galaxies began to form. The young universe was not calm. Small structures collided and merged again and again. Each merger could compress gas and ignite waves of new stars. The ultraviolet light of young stars carved holes in the neutral hydrogen fog. These bubbles grew until their edges touched and merged. Not every photon escaped, but those that did helped transform the universe. By reading ancient light, scientists can detect the gas it passed through.
Little by little, the primordial fog was torn open. Where dark matter gathered, gas fell inward, stars were born, and galaxies grew. Galaxies needed fuel, and cosmic rivers fed them for hundreds of millions of years. The farther we look, the deeper we look into the past.
Every photon that arrives is a memory from the young universe.
From cold data, scientists reconstruct a story of fire, gas, and time.
A spectrum reveals chemistry, temperature, motion, and distance.
In a patch of sky that appears empty, thousands of galaxies may be hiding. A faint red dot can be light from a time when the universe was still young.
Ancient galaxies were not calm spirals. They were dense, chaotic, and energetic. Modern galaxies often look more organized. Young galaxies looked like construction sites in motion.
Not every part of the story is directly photographed. Some of it is rebuilt through physics.
Simulations let us test how gas falls, how stars form, and how radiation spreads.
Behind cosmic beauty are laws precise enough to shape galaxies. From atomic scales to galactic sails, gravity remains the quiet director. The night sky is not a single moment. It is an archive of many ages. Some light takes only years to arrive. Some has traveled for nearly the age of the universe. When we reverse time, the universe becomes younger, simpler, and more violent.
Even today, stars are still being born in enormous cosmic nurseries. Starlight shapes and destroys the very clouds where stars are born. Inside the densest shadows, the future of light is forming. Young stars are rarely born alone. They often emerge as large families. Over millions of years, clusters loosen and send their stars into the galactic sea. Some stars follow a quieter path, burning steadily for billions of years. Around stable stars, planets may have time to grow and change. But a planet also needs time, chemistry, and stability. A star's energy controls climate, radiation, and the fate of nearby worlds. Too close, water may boil away. Too far, it may freeze. Distance becomes destiny. Small red stars shine dimly, but can live for extraordinary lengths of time. Giant blue stars offer overwhelming energy, but their lives are brief. They live like a dramatic symphony, short, loud, and unforgettable. A galaxy is a library of many generations of stars. Not every star dies in a grand explosion. Many release their outer layers softly into space. The remaining core becomes a white dwarf, the hot ember of a finished stellar life. It will cool over times longer than human imagination. The life of stars is not a straight line. It is a vast cycle of matter. In spiral galaxies, the arms are places where gas is compressed and new stars flare into being. Those spirals are not only beautiful, they trace density waves and flowing gas. Near the center, older stars gather densely, giving off a golden, ancient light. At the far edges, gas is thinner and stars are fewer, yet the universe still builds in silence. Some star clusters are so old, they preserve memories from the youth of their galaxy. And our galaxy is only one island in a luminous cosmic ocean. Imagine a universe made only of hydrogen, helium, and darkness. Stars turn that simplicity into energy. In massive stars, simple matter is upgraded into complex elements. The explosion releases those elements, so they are not trapped forever in the stellar core. The next cloud is no longer primitive. It carries the memory of earlier stars. From that material, rocky planets, ice, metals, and complex chemistry can emerge. One day, on a small world, starlight may become the rhythm of life. Energy from a star can move atmosphere, ocean, and chemistry. The elements in rock, water, air, and blood each carry cosmic history. Even the matter in our bodies once passed through the hearts of stars. That violent climax was not only destruction, it was origin. The universe operates through cycles: collapse, ignition, transformation, release, and rebirth. Each generation of stars writes another line in the universe's chemical book. A mature galaxy is the result of billions of years of stars living and dying. When we look at the sky, we see more than the present. we see inheritance. Through science, we learn how to read that inheritance.
At the edge of what we can observe, the earliest galaxies are still sending messages.
A single photon can carry news from when the universe first learned to shine. From faint signals, we rebuild lost cosmic dawns. Each image is a layer of time. Today's stars are different from the first stars, but they obey the same struggle: gravity against energy. Somewhere, another cloud is collapsing. Somewhere, another core is heating. Somewhere, the universe is turning on another light. From the first darkness to today's star-filled sky, the story is written in physical law. Stars operate through balance. The universe operates through change.
The smallest and the largest things are connected.
A planet may seem like a small companion to a star, yet sometimes it becomes where the universe looks back at itself. Every star is a question, and every question pulls us deeper into time. We were born late, but we learned to look far. Light from the past is still arriving, and the story is not over. The first star is long gone, but its influence may live in everything that followed. From invisible gas to light, from light to elements, from elements to worlds. And it all begins with one ray of light, strong enough to cross the dark. The age of stars is not just a chapter in cosmic history. It is the engine, the memory, the furnace, and the heartbeat of space. When we look upward, we do not merely see points of light. We see how the universe learned to operate. In the next episode, we will enter the first cities of light, the earliest galaxies.